Right, I will show you how to solve inequalities using UTI-84. So the inequality we'll be solving is 3x squared plus 5x is greater or equal to 2. Notice I'm not going to rearrange this inequality into 3x squared plus 5x minus 2 is greater or equal to 0. The way of solving this and this inequality is analogous, so if you follow this process you will be able as well. Right, so how are we going to do that? We're going to split this inequality into two functions, y1 and y2. As you see, I have entered them onto my calculator. That's y1, that's y2. Now we need to set up a logical comparison operator or statement. And how are we going to do that? We go to vars. First of all, make sure you are in y3. This is going to be our y3. Alright. So we're going to go to vars, go to vvars, go to function 1 and click option 1 for y1. Then we need to get this comparison operator. We go to second, test, option 4. Then we would like to get this variable y2. We go to vars, vvars or yvars, sorry. Go to one function, option 2. This is our comparison operator there. Now I'm gonna hit graph and we're gonna see some magic happening. Right, the blue is our parabola y1, the red is our y2, and the black line is our comparison operator. So let me draw this onto my paper and I'm gonna explain what's going on. Right, so the blue is our parabola. Perfect. Now the red is our equation of the line, y2 is equal to, and this one is y1 is equal to 3x squared plus 5x. And the black line, this one, is actually the comparison operator. So I'm going to draw here and there and a bit lower here in the middle. Right. This black line tells us that the parabola here is above y2 equal to 2. It's above here as well, whereas here in between is below y2. The only thing remaining is to find exactly the points of intersection of these two lines. So we're gonna get some values, exact values. This is only a pictorial way of looking at this, but we need to find out exact values. So to find this intersection, we're gonna go to second and calc. We want to go to 5 intersect. And we want to find out where the blue intersect with the red. So what we're going to do is I could just go directly onto, try to go into the place when these two lines intersect, and I'm going to click enter. The calculator will ask me for second curve. Well, it's indicating the black line here. Well, I don't want this black curve, I want, I believe, the blue curve or the red one. It needs to be blue and red. I'm gonna click enter, and actually it's asking for the second curve now, so I'm gonna go to the blue. Perfect, enter, and it's asking me to guess. Good, and I got this intersection here is 0.3 repeating. Repeat the same process onto the other side there. So I'm gonna go to second calc, 5 for intersect. I'm gonna go to the other side And I'm actually specifically going to use the blue line now. So I'm choosing the blue line, the parabola. And now I'm choosing the red line. As you can see, the red line. So I click enter. The calculator asks me to guess, yes. And gives me the intersection, which is -2. Perfect. Well, now I know everything. But for clarity, I'm going to draw a number line. I'm going to copy these values down here. So this is -2, this is 0.3. Now, I want greater or equal to, so we are including -2, we are including 0.3 repeating, and I want to find out where this is greater or equal to 2, where it is greater or equal to 2 on this side and on that side. So these are my solution inclusively, and on this side as well. So I can write my answer that x is a member of, and I can actually write the intervals, union right. Well, alternatively, you can just write that x needs to be less than or equal to -2, or x needs to be greater or equal to 0.3, repeating 1/3. Well, so that's how we're solving inequalities using CGI. There's another way of doing this on my PowerPoint presentation.